Hello friends, welcome to the channel Physics by IITians. Today in this topic we will discuss about the conservative vector fields. What are those fields and what are their basic properties so that we can identify whether the particular vector field is a conservative or not. So first, the conservative vector field is a field that is a gradient of some function. Means if I am writing a field f, so if it is a gradient of some function phi, then we will call it f as a conservative vector field, but before that it has to satisfy certain properties, and this phi is called a potential or a scalar potential. What are those properties? One property is that the vector field should be path independent. If you are moving from point A to point B, and you may choose any path, you may directly go to B or you may go like this and then go to B. If the going from path A to path B, going from point A to point B through different paths, there is no change in work done, then we will call this field as a conservative field. Means the work done is path independent. Another property is that it should be irrotational. What is the meaning of irrotational? If the curl of this vector field is 0, we will call it a irrotational. And for a irrotational vector field, or for any certain vector field, we will define vorticity. Vorticity is defined as the curl of the function. So here, if I am defining vorticity by the symbol omega, so it will be curl of V. And if the curl of V is 0 for a conservative field, so the vorticity will also be 0. So you can say that for a conservative vector field, the work done is path independent, function is irrotational, and the vorticity is 0. Let's discuss a question for the conservative vector field only. The question is like this: a vector field is given to you as f equal to 2xy plus zq I cap plus x squared j cap plus 3x z square k cap. This is the vector force field given to you, and the question is this a conservative field? And if this is a conservative field, we have to find the scalar potential phi. So firstly, let's check whether this is a conservative field or not. And for this, the curl of this function should be 0. So we have to calculate the curl, and curl is defined as I cap, j cap, k cap. You have to solve this determinant del y del x, del y del y, del y del z, and here you will write the x component, y component, and the z component respectively. So the x component is 2xy plus zq, y component is x square, and the z component is 3x z square. So if we solve this function, we will get that the curl is coming out to be 0. And if this curl is coming out to be 0, we can say that this is a conservative field. Now we know this is a conservative field, and any conservative field can be written as the gradient of a scalar potential. So we have to find now the scalar potential. So we are defining f as gradient of phi, and gradient of any scalar potential is written as del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. If we compare the I, j, k components of this gradient with the function, we will get that the del phi by del x is 2xy plus zq. Now, as this is a partial derivative, you can easily integrate this function and you can find the phi. So phi will be x square y plus x zq, and also we will have a certain constant terms. As the integration is being done with respect to x only, so the constant may be a function of y and z, but it should be independent of x. So this is a constant f y z, means the function f is a function of variables y and z. Second, if we compare the y component, then you will write del phi by del y is equal to x square. So from here again you can find the phi. It will be x square y by integrating this equation plus function f. And now in this case the function is of variable y, x and z. Y is treating as a it is independent of y actually. Similarly, del phi by del z will be equal to 3x z square, and again you can integrate this equation. Then the phi will be x z cube. If we compare these three equations, we can say that this phi is having two main terms, that is the x square y plus x z cube. So this phi you can write as x square y plus x z cube. So this is the scalar potential for this conservative field f. Now, there is an announcement. We have a test series program called TSP, and there is another interview guidance program, IGP. You can join this program by clicking on the link given in the description. The interview guidance is for PSD, integrated PSD interviews help, and the test series program is for test series of NET and GATE exams. Thank you.